Hey everyone. So welcome to this video where we're going to do a practical introduction to building workflows, right? And as we know, workflows have become very popular over the last few years, especially with the arrival of AI, right? Uh, and workflows, the reason they've become so popular is they allow, make possible solving complex problems in a modular, sensible, right? So in our case, let's just quickly look at an example. The idea is we have a cart of information here, right? Assume it's a checkout, from an e-commerce store, for example. And so we have this information, which is an order. Think of it as coming out of a cart. And what we want to do is convert that into something like this, which is an invoice, right? So it's a very simple workflow, but I think it should help you get an understanding of what workflows are and how you can build them fairly quickly. And then in the next few videos, and this is kind of a short series where we will start exploring more complex workflows, how to put AI, LLM calls into your workflows, build multi-step LLM flows, and then agents and agentic workflows eventually, right? Now, the basic idea of a workflow is you have a problem that you need to solve. In our case, we want to convert the order into an invoice, right? Um, and an invoice just in the form of a string. What you can do with a workflow is take that task and break it into a number of small sub-problems or sub-tasks, right? So what you end up doing is saying, actually, I have 3 steps here, right? Right. And what I can do is by breaking it into these 3 steps, it makes it much easier to solve this problem. What that allows us to do, just a quick reason why workflows are so possible, is it allows us to automate, right, a lot of complex tasks by breaking it into steps. It also makes it possible to be very modular and reliable. You have pieces that you can replace without touching the entire piece of code. You can inspect and observe different issues, debug fairly quickly. And it makes it very easy with AI coming in to integrate AI models and LLM calls or other tools into different parts of the workflow, making your workflow intelligent. So in our case, right, let's say we have 3 functions, right, or 3 pieces of the puzzle. That it's going to take that order you had and convert it into a receipt, right? And you don't need to worry about the code. I will show code and kind of this is a practical introduction, but you should be able to follow even if you don't get the code, right? So you have an order parser which takes in a dictionary, which is the order, which is just the data associated with the order, and it convert and it creates what is called a subtotal, a sum, right? You have a tax calculator, and in our case, it's very simple. It just assumes, the Indian tax conditions, and it assumes 18% GST. You can make this more complicated and returns the tax. And the third function, which now takes this information, so it takes in the order, the subtotal, and the tax, and formats it into a nice looking invoice, which you can then extend this and add a file exporter, which will take this and convert this into a file, right? But this is our, how we've broken down our complex task into these pieces. So you can see each piece is very simple and modular, right? And it kind of handles a very specific part of the original task. Now what we need to do to make these functions a workflow is workflows typically, the way or where the action happens is called a node, right? So it comes from the idea of graphs where you have nodes and edges, right? And so we have effectively what we need now is 3 nodes. You have an order parser, a tax calculator, and invoice generator. So you'd think, well, we've already seen the function, right? We have what we need to do is now take that function and convert it into a node in the workflow so that the workflow understands now that this function is there and it has connections to other pieces of the puzzle. Now we've seen tools out there that are pretty useful for this, fairly production level tools, either code based like LangGraph and so on, or you have N8N and so on, where you can use arrows and kind of using a UI connect it. We're going to use a simple tool we've built for this. For this example, it's called Laeyerz. It's on GitHub. It's a very simple tool with no dependencies. So you can go to GitHub and set it up. You just have to go and the repository. I'm giving you the repository URL here. So you just go and say git clone, and you will get Laeyerz. Go into that repository and do a pip install -e. So it's a minimal dependency thing. Should be very easy to set up, right? And I haven't set this up on pip as of now, but I will soon. So kind of for further tutorials, you'll find it very easy, right? And so now that you've done this, let's quickly take a look at the code, and that should help you kind of see how quickly we can take that function, which is good, but convert that into a node that a workflow understands, right? So let's do that. So I'm assuming you've gone ahead and installed Laeyerz from the Git repository, clone it from this repository, and then install it. Minimal dependencies, so it should only take a few seconds. And so we'll do a quick practical here. You get to see in practice how we can build this workflow, right? And so if you want to check out this example in full, the code is available here in a different repository to Laeyerz. It's Pixagan, Laeyerz examples, and there's this example and a few more which we'll be seeing over the next few weeks. So all we need in this case is to import flow and node from Laeyerz, right? Laeyerz.flow.node and Laeyerz.flow.flow. Now we've got our first function. We've seen the three functions, in a few seconds ago, where we needed to convert that now into nodes of the workflow, right? So the parse order takes in a dictionary which contains a list of items with a price and quantity, and what we need to do is get the total for that, and that's our first node. So what do you do? Well, first what we need to do is create the node, right? So in Laeyerz, all you do is say node 1 is node, and you give it the name. So I'm calling it order parse, and giving it the name is important, right? It will help us identify the nodes as we run it. So I'm just running those nodes, and now you've run this. So it sets up order parse. Now what we need to do is define the inputs and the outputs. What are the inputs to this? It's just a dictionary saying order. So I'm going to say node inputs, which in Python is, we're going to set it up as a list of inputs. There's only one input, so it's a dictionary. The name of it is order. The type is a dictionary. It's the type here, right? And I mean, you can always automate this, which we will do later. But for now, let's specify the inputs explicitly, and the description of what the order is here. The reason we're giving this here is when we get to agents, in a little while, in a few videos from now, this kind of node can be used by agents as well. And we leave the source for now as empty. What you also need to specify are the outputs of the node, right? What is the node taking in and what is the node giving out? So the outputs, we see a subtotal. So it's a node that takes the order and gives out the subtotal, which is just a number, a float, right? Floating point number. So let's set this up. Now we haven't passed these to node, right? We haven't given it the function either, and that's the next step. So to set up the node, what you do is, now that you've created the node object here, node 1 is node order parser, what we'll do is say node1.set function, give it a name for that function. So we're calling it parse order, give it the actual function, which is this. So we've defined that there. This is supposed to be parameters, which as of now in this example, you don't need to worry about, and then give it the inputs and the outputs. And when you do that, now this function has been converted into a node, right? And why are we doing that? Again, so that we can now plug that into a workflow, and the node now understands that it's got this particular function, takes in these inputs, takes in these outputs. The other reason we're giving this name, and we'll see this when we tackle more complex examples in the upcoming weeks, is in Laeyerz, a node can have multiple functions, right? So you need to give it a name so that you can identify which function you're calling. So let's test this. So what do? We'll just create a dummy order. So I'm going to call this order. And as we know, it takes in a dictionary, and in the dictionary, it looks for, right, order items. So we are saying there's a dictionary. In the dictionary, there's an object called order, and order has an ID, a customer name, and items, right? And we're going to use this order ID and customer name when we generate the invoice later on. Once we create that, what do? We say node.run. We specify the function that needs to be run. So in this case, it's parse order. And because a node, as I said, in complex examples can have multiple functions. And we give it the inputs. The reason we give the inputs like this is because actually this is one piece of a workflow. And the inputs actually would be inputs to a workflow which could have multiple values, right? Order is just one set of inputs to this node, but you could, in complex examples, have inputs to, other functions or other nodes as well. So let's set this up and run. And you see what it gets. It takes in the inputs, these are the inputs, and then it generates subtotal, which it returns. And I've kind of set it up so that you can see each step internally kind of with prints, right? So we see that this node, pretty straightforward, it's taken the function in and the inputs and the outputs, and when you run it, it takes the inputs in, gives you the subtotal, right? Which, as you can tally, is correct. So that's how you set up a node, right? We can do the same for the others, and I've already set that up here. So for calculate tax, it takes in subtotal floating point value, and just multiplies that by this. And subtotal we have just computed above, right? How you set up the node is the same. You define the name, you set up the inputs, set up the outputs, then call set function, pass in the inputs, outputs, and the function along with the name, and you're done. And the third node is the invoice generator, which is now slightly more interesting. It takes in the original order, the subtotal, and the tags, right, as we've kind of talked about, and it kind of formats it into an invoice. And you could add one more to this if you want to extend this, where you can then have some export or print, right? So the inputs here are more complex. There are three inputs: order, subtotal, and tags. So order, which is a dictionary, subtotal float, and tags is a floating point, and it returns what we are calling an invoice, which is the name here. And in functions, if you're using layers, you're playing around with layers, I'd recommend using a dictionary to export the values, right? That kind of works best. You can export just a floating point or something, but it makes sense actually to do it this way. So we've created our three nodes, right, pretty quickly. Are we done, right? Can we just run this? Well, the answer is no, right? Obviously, you've already figured this one out. We've created the nodes, but how have we kind of built a flow? Or how have we connected these things? We haven't. So what you need to do now is we've imported flow, right? When we started this kind of demo, what you need to do is create a flow object. If flow is flow, and we give it a name, e-commerce order flow, right? So now you have a flow object, and then what you need to do is add these nodes to that flow, right? So now you've created the nodes, meaning those computational blocks are ready. They know what each input and output is, but to create a workflow, you need to now take the workflow, add these nodes, and then define the connections. So you say flow.add node 1. We've called these node 1. The naming is pretty elementary: node 1, node 2, and node 3, as you can see. So you can give it better names if you want, but flow.add node. And so now the flow object, which is the workflow, now knows it has three nodes, and it also knows what each node requires. Are we done? Not yet, because we have defined the workflow. But now how does the orchestrator, the Laeyerz workflow engine, know how to run this? What inputs it knows what inputs each node requires, but where do these inputs come from? Are they fixed values? Are they connections, and so on? So let's define that piece of the puzzle next. Okay, so now that we have created the nodes and added them to a workflow, so now the workflow understands the pieces of the puzzle. Well, are we done? We're not, right? Because if we now hit the run button, let's say, how does this work, right? The workflow doesn't know where it's going, what data, it knows what each node requires, but doesn't know where that information is coming from. So the orchestrator, which is in this case the Laeyerz workflow runner, which is what is running the workflow, has no idea how to go forward. So what we need to do is define a few more pieces. Now, when we run a node in the workflow, we need to know where the data is going, right? In our case, we took a set of inputs and we ran it in that node. We ran an example node in Python. We got an output. Where does this go? So, workflows have what are called app states or graph states or flow states. They're called, however you want to call them, one of these, where the values are stored. So when I say inputs, what it does is the orchestrator goes in and stores that in the app state. It says, okay, there's inputs and there's this variable called order. It's a dictionary. I'm going to store that value. Similarly, when you run the other node, in this case, if it's part of the flow, that is, and say I run the first, order processor, right, which computes the subtotal, it's got the inputs. We'll see how we get the connections, but it takes the value from here, this order, and the output it generates is stored. The output is called subtotal. It goes and stores that again in the app state. So you can think of an app state as a local dictionary or a local memory piece of the workflow that it uses to store the internal state of these nodes, right? And in our case, in Laeyerz, it also stores the inputs, right? So that then is kind of the memory of that flow. And for each time you run that workflow, its internal state is stored. And then what do you do? Well, once the internal state is there, these pieces. What you need to do is define the data connections, right? What do we mean by that? Well, where is this information going? We know this node needs order. It generates subtotal. We know this needs subtotal. It could tax. We know this needs everything. But the workflow doesn't know that. So we have to explicitly tell it what these connections are. So what we're going to do is define what we call data connections or data edges. So we're going to say actually order, which is an input, is connected here to this input, which takes in the order. We're going to say for this node, the input is subtotal, which actually is coming from here. It's the order passer's output. Similarly, for the invoice generator, it actually has three inputs. The order, which is received from the inputs, right? The input to the workflow. The tax, which is received from the tax calculator. And the subtotal, which is received from the order passer, right? And the output of that is the invoice, right? Which we will set up later as the output of the work. So defining these data connections is important so that the orchestrator of the workflow understands where to go and grab that information when it's running. So let's quickly go run this in Python, right? Set it up, run it. It'll take a few seconds and we'll be back. Okay, so we've kind of seen visually in the slide how the data connections need to be defined, right? So the orchestrator knows kind of where to get the inputs for these nodes, right? Whether it's from the input you're passing into the workflow or their outputs of the other nodes, right? And defining it kind of with, let's just quickly define that now in Laeyerz so we can run this workflow in a bit. So again, not very hard to do. It's kind of like the arrow you saw there. What we need to do is say add data source and then specify to which socket, as I call it, the data is coming into. So which node, order passer, as the first node. Which function of that, as I had mentioned, you can have multiple functions in Laeyerz for a node. In this case, it's parse order. We've just checked that above, right? When we looked at when we defined the node here, order parser, and it was called parse order. So that, and the input name was order, right? And where is this value coming from? So this is the source. So this is the receiving node. This is the source. The source, if it's just from the input to the workflow, they're all stored in inputs. So you just say inputs, leave the dash, and then say order, right? And that's it. The inputs, as we have seen in the example above, we created a dictionary and said inputs order, right? When we ran that node. So it's the same principle. So you specify the receiver, which is the node, the function, and which input it's going into, and the giver, right? The source, which is the inputs in this case, and order. Now, what are the other connections? Well, for this node, that's that. What about the next node? Well, the next node, tax calculator, takes in the the subtotal, which is what the order passer generates. So we're going to say, well, the tax calculator requires a subtotal. The function is called calculate tax, and it gets it from order passer, parse order, which is the function, but order was the input to that. Subtotal is what it returns, and that's that. And the third one, which is more interesting, there are three inputs, right? So you have to define all three. It's effectively the coding way of drawing that arrow, right? Where you say now invoice generator, which is the third node, has the function is, or the action is generate invoice. It takes in the order, which goes from the inputs itself, so inputs order. It takes in the subtotal, which is from the tax calculator, so order passer, actually subtotal is from order passer, so order passer, subtotal, and then the tax, which it takes from the calculate tax mode, right? And that's that. You have defined your connection. So it's really easy. And the advantage of a workflow, as you can see, is if I want to rework this, I want to add one more module, or I want to update the calculate tax or something like that, I can change these connections by changing an arrow, in this case changing a line, and my data connections are modified. And it also means I only have to modify any one node or module to upgrade or change systems, right? I don't have to rewrite a lot of code. So you're starting to see the benefits of a workflow. So we've defined now how the data flows, but that doesn't mean the orchestrator now knows which functions to run. In this case, it's a very simple example, and so you can easily get it to understand that the data dependencies are in this format. It needs to run this, this, and this, right? But that might not be the case in more complex examples. You might want to run multiple nodes parallelly. So what we need to define next are the flow of control in terms of control edges for this workflow. So let's kind of go look at how we do that, right? So now that we've set up the data connections, next let's go define the flow of control, right? Now this is another important concept because the orchestrator now knows the connections, but in this example, actually, it's quite obvious what the flow of control should be, meaning which nodes need to be executed in what order. This needs to be executed first, and this and this. But in more complex workflows, it might not be so obvious, right? You could have nodes you want to run in parallel, you might have conditional nodes and so on. So what you do is define the flow of control in the form of, control edges, right? And so what that does is you tell it, well, this is start. The first node I need to run is the order parser. Then after order parser is run, the edge tells it actually now go run tax calculator. Then the next edge, which will tell it to go run the invoice generator. And then finally, that's it, you're done, right? So end. So this is defining the control flow in the workflow. So let's quickly go do that in Laeyerz. Now in tools like LangGraph, for example, you have to implicitly handle the data control. It is done by just importing that from the app state, but the flow of control has to be specified, right? In our case, we have specified both explicitly, right? Okay, so now in terms of code, let's actually implement the control edges, right? And in Laeyerz, again, you just call it add edge, and add data source is the data connection, add edge is the flow of control in Laeyerz, right? And it's fairly straightforward. The first node, the node that runs first, you have to say start, which is this, and then which node it is. So in this case, with edges, you go from which node the connection or the flow of control is going to which node the flow of control is going, right? So you say it's going from start to order parser, parse order. And again, you have to give the function name because order parser could have another function under it. And we'll see that in different examples in future videos. And so you have to specify that, right? So source function and target function. So in this case, the source is start, which just means the beginning of the workflow. And the orchestrator looks for start and then finds what node is connected to that, right? Then what happens? From order parser, as you can imagine, it goes to calculate tax. So we say, well, now order parser, parse order to tax calculator, calculate tax, right? The third connection goes from there to the invoice generator. And so once you've passed the order, got the total, calculated the tax, goes from tax calculator, calculate tax, to an invoice generator, generate invoice. And actually you're done, right? So how do you define or tell the workflow you're done? You don't need to, but I strongly recommend you do. You say invoice generator, generate invoice to end. When it hits end, the orchestrator knows the workflow is done. So again, as simple as drawing the arrows, you just point to each action or function associated with that node and tell it once it runs that, what's the next thing it needs to run, right? And so when it kind of finished running this, it looks for this edge to see where it's supposed to go next. And these are very simple, straightforward edges. There's no condition, there's no running in parallel and so on. We'll do those in more complex examples in the future, right? So again, fairly straightforward workflow. And once we're done with setting up the edges, what's next? Next is actually running the workflow. Okay, so let's go do that. So now that we've gone and specified the edges, we now have all the pieces of the puzzle, right? We have the nodes, we have defined that, the flow nodes that, we have told it how the data is connected, and we've also told it how to handle the flow of control. So the orchestrator is ready to go. And so what we can do now is go ahead and run Laeyerz. And when we go say run, the Laeyerz engine goes ahead and starts looking at those information, goes to start, looks at the edge, figures out which node is needed to be run, gets its data, imports that, runs it, and keeps going till it hits the end. So let's quickly go and set that up in Python. Again, it'll take a few seconds and we should be done. Now that we've kind of set up the nodes, set up the edges, set up the data connections, and we've visualized kind of in the slides what we are up to, let's now run the workflow. Now to do that, let's just one line I'll add here, which is set outputs, right? This is optional, you don't have to do this, but you'll see in a second why I'm saying I want the output to be invoice generator, generate invoice, which is the node, right, to generate the invoice. And I want the output of that, which is invoice, to be set as the output of the workflow. We've seen this input data already, which is, when we ran the node, this is exactly what we used. Now the idea of having order, which was the input to that node, if you have a more complex workflow, you have multiple items. This is a dictionary, so order, you can say something else like, I don't know, info, and add something else like that, for example, and those will be treated as inputs, right? In this case, we don't need that. And then running the workflow is as simple as saying output is flow.run input data, right? Which is, if you were using workflow tools, you just hit a button, and that's kind of the idea here, right? And the reason we do this is so that when you say output, right, if an output has been set here, and this is a list, so you could specify more outputs as well, but what it does is it looks to see if you have set something here, and if so, it goes and extracts those values and returns a dictionary of those values or states, which means you can then visualize it, or you can have connected workflows and export it, or if it's an API call, you can return it to the API, back to the to the user on the other end of the API. And that's the idea, right? Otherwise, what you have to do is go in and search the app state, which you can do, but why do that, right? So let's go run this. And so you see that it starts the workflow, order parser, calls that, gets the subtotal, calls the tax calculator, gets the tax, and then finally it says, great, I'm going to generate the invoice, which is just a string formatter. It gets the order, the subtotal, the tax, and you're done. And so this is the internal running. Now I've got the output here. So if I say output, it's just gone, invoice generator invoice, which is the output we wanted. I've left a line space here, which is why this space, and it gives you the invoice. So if you have an API call, for example, calling this workflow, set it up with fast API, you can see how the workflow now runs and returns this value. So that's kind of fairly simple, right? You've seen how a workflow works. The idea here is to give you a simple intro to how a workflow works. Now, right? Okay, so let's go back to the slide for a bit. So we have run that workflow, and it was pretty fun, right? We got to see how we could break a problem into small pieces, set up those things as a workflow, and you can see now with the advantage of a workflow is each piece of the puzzle is very well defined, but it's also modular, right? I could take this, if I want to change how the tax is calculated, I could just change this piece of the puzzle without touching anything else. If I want to add something else, I want to add here, an export that actually downloads the file, I can just add another node and say download. I don't need to touch anything else. So it makes it very easy to see how each piece runs. We saw there how when each piece runs, you get the output, and you can see very clearly how, oh, this piece is generating this. So it makes it observable. It also makes it easy to modify. And now if you want to make this smart, you have something that an AI needs to do. It needs to parse an old order or something. You can add an AI node here, right? And that is where, again, workflows becomes even more powerful because they start becoming intelligent. So now the next tutorial we'll do, right? The next video, we'll now build an AI-powered workflow. So you'll have AI coming in and being part of multiple nodes, and we'll see how you can use LLMs to kind of solve even more interesting problems, right? And how actually instead of using one big LLM call and kind of confusing the LLM, we can use multiple LLM calls to kind of solve fairly complex problems in an interesting way. And like I showed you in the code, the example that you've seen here, if you want to try it out, you can go to Pixagan, GitHub, Pixagan Laeyerz examples, and billing workflow is the example. So hope you enjoyed and learned a little from this. See you in the next one.